Imagine buying a new smartphone, automobile, laptop, or other electrical gadget and not having to worry about it needing to be charged. With the development of a new form of battery that uses nuclear waste from reactors to generate electricity, which can then be used to power all electronic gadgets, this is now achievable. A single charge of these batteries will keep them running for more than 28,000 years. Cars powered by electricity are reshaping the landscape. Automobiles powered by batteries are quickly overtaking gas-powered models as the preferred mode of transportation for many automakers, and Toyota is at the forefront of this development. Join us as we examine how Toyota finally reveals the new nuclear diamond battery. Technology would be incomplete without batteries. The vast majority of the electronic devices we own today make use of them. Despite their importance, there have been few developments in this unit over the years. In contrast, the battery core hasn't changed in decades. Lithium and other related chemicals are used in the same way. Alternatives to lithium-ion batteries are now readily available and are expected to take their place in electronic devices in the years to come. Improved charging time, capacity, and reduced size are all advantages of this technology. The holy grail of battery technology is being sought by a slew of automakers and other businesses, including Toyota. Toyota has several new improvements in the works that will expand the range of vehicles available to drivers seeking to reduce their carbon footprint. Toyota is at the forefront of battery technology development, and its self-charging hybrid electric batteries have given the company over 2 decades of battery experience. Solid-state battery electric vehicles, which they've been working on for a few years, are the next big game changer in the sustainable driving and have been alongside their hybrid electric line. Battery electric vehicles, BEVs, are becoming increasingly popular around the world, but the fire hazards and quick degradation associated with EV batteries have turned off some potential buyers. It was last year that GM and Hyundai had to recall their electric vehicles because of complaints of fires caused by batteries manufactured by LG Energy Solution. BEVs require hours to charge, and quick charging methods might cause the battery cells to overheat, resulting in degeneration. As a result, cruising range decreases over time, lowering a vehicle's resale value. Solid-state battery technology from Toyota helps the company balance these 3 factors: range, deterioration, and charging speed. So what exactly is solid-state battery technology? Solid-state batteries, as the name implies, use solid electrolytes instead of liquid ones. In terms of size and thickness, their prototype batteries are comparable to a thin, spiral-bound notepad. The short range and long charging times of electric vehicles powered by conventional lithium-ion batteries may be alleviated with the development of solid-state battery technology. Sulfur-based electrolytes are a more efficient alternative to lithium-ion batteries, and Toyota is focusing on employing them in their prototypes because of this. Reduce the risk of fires and increase the battery's energy density. Compared to lithium-ion, next-generation batteries like solid-state and metal air are safer and more efficient. The coolant in Toyota's batteries, developed in collaboration with Panasonic Corporation, is supposed to make them less susceptible to electricity flow. In the event of a leak, the battery packs are designed to keep the cells and coolant separate. More than 90% of the new BEV battery's capacity will remain after a decade thanks to these and other advancements. As the first business to mass build a viable solid-state battery, Toyota plans to deliver an electric vehicle equipped with a solid-state battery by the mid-2020s. In terms of the end user, what does this mean? 700 kilometers on a single battery charge. It takes about 10 to 15 minutes to go from 0 to 100% charged, all of which can be done with minimum risk to one's health or safety. For electric vehicles and the industry as a whole, Toyota's new solid-state battery represents a game changer. It's expected that solid-state battery vehicles will be able to travel more than twice as far as a conventional lithium-ion battery-powered vehicle under the same circumstances, achieved in the most compact vehicle without losing interior room. By utilizing modern lithium-ion and solid-state technology, Toyota intends to raise battery efficiency by 30% and lower battery costs by the same amount in the near future for all of its BEVs. By the second half of the 2020s, the business expects significant improvements that will increase efficiency and reduce BEV production costs by half. The nuclear diamond battery could be the solution to everything The battery is on a completely different level and it could change the world. There's talk of never-dead batteries. According to the San Francisco-based company, the high-power diamond-based beta, alpha, and neutron voltaic battery is capable of providing gadgets with long-lasting and environmentally friendly energy, which would change the game. NDB claims to have created a nuclear waste-derived self-powered battery with a life expectancy of 28,000 years, making it ideal for your next electric car, iPhone, and other gadgets. The battery is constructed of two types of nanodiamonds, which makes it basically crash-proof if utilized in a vehicle or other moving item. The nanodiamond battery, according to NDB, is self-charging and environmentally beneficial. It might be used to power smartphones, electric vehicles, drones, and a variety of other devices. Polycrystalline diamond covering is used to store the energy source in these batteries. In addition to its durability, 12 times that of stainless steel, the battery is made robust and stiff because of its thermal conductivity, which can store radiation inside the device. So what's the deal? Lawrence Livermore National Laboratory analyzed the proof of concept for producing NDB and found a 40% increase in charge efficiency over the diamond. There are a few steps involved in the extraction of radioactive graphite from nuclear power facilities. These removed radioactive leftovers are currently disposed of due to their danger. To avoid any live interaction, these items are placed in a container and thrown into deep sea or volcanoes where they will eventually decompose. Radioactive graphite is treated and purified in order to remove it from the environment. The batteries can then be made using layered structures of carbon. Diamond nuclear voltaic DNV batteries have two contact surfaces for charge collection and are made of a combination of semiconductors, ceramic, and metal. Many units are put together in the shape of a stack, where construction and positive and negative surfaces are generated in the same way as a traditional battery system, but with a higher output source. Because of a single crystalline diamond in the system, the radioisotopes in these batteries aid in inelastic scattering. A polycrystalline diamond layer is applied to the stacks and the source at the same time. These batteries, which feature several stacked diamond layers, a small circuit board, and a supercapacitor for collecting, storing, and discharging energy, will be produced by NDA in a variety of common and unique sizes, including AA, AAA, 18650, and 2170. With this battery, it appears that long life is possible. They could even be useful for spacecraft that need to operate for long periods without assistance, according to NDB. Satellites, for instance, are one example. As a side note, an average human would have died 400 times and more than 1,000 generations would have elapsed before this battery runs out of charge. There is also a consumer product in development that might power a smartphone or electric car for over a decade with no charge. The company estimates that a single battery could power multiple pairs of wheels for up to 90 years, which is considerably beyond the lifespan of any single vehicle. Aside from the convenience of not having to worry about recharging our devices, this is also a significant step forward in understanding the environmental impact of battery production and disposal. A major concern is the safety of the product. Is it safe even though it generates power by the use of radiation? The diamond layers collect charge while also preventing radiation leakage. The radiation levels emitted by the cells, according to NDB, will be lower than those emitted by the human body. It is therefore safe in accordance with this viewpoint. Even so, it's important to remember that no actual batteries are used in the testing process. These nanodiamond batteries have a charge efficiency of 40%, which is significantly higher than that of commercial diamonds, which only have a charge efficiency of 15%. A leading global aerospace, defense, and security manufacturing company and a leader in nuclear fuel cycle products and services are among NDB's first beta customers. Prototype batteries for long-duration missions are currently being developed, and NDB expects to begin selling them to commercial partners, including space agencies, within the next 2 years. Let's see if it comes to fruition, and if it does, the tech industry is going to be forever changed. If successful, it could significantly reduce the cost of lithium, removing one of the most significant bottlenecks to battery production ramp-up, bringing us back to the original premise that these nuclear diamond batteries will be the most transformative for Toyota. We'd like to know what you think in the comment section below.